about 4 years ago, we started to say, hey, what else can we do so that the interim, keep the broadcasters on air and get them more efficient, which actually is the reason why we introduced MPEG-4 into ATSC 1.0 to try to get additional programming, because a lot of programmers, a lot of station owners are complaining that they could use additional bandwidth. They said, we like ATSC 3, but hey, I wish I had additional capacity in my ATSC 1. So we said, hey, you don't have additional capacity, the bandwidth will be the same, but we can put in more additional programs by converting to H.264 or MPEG-4. By the way, that's supported by the standard since 2009. So this is why we kind of went in that direction. And one of the big things that maybe Jeff will talk about is our mixed mode StatMux that we developed in order to enable this to happen. So Jeff, you want to talk about?
Sure, I can discuss that. And just to add to what you were saying, even with H.264 and ATSC1 and our customers, meaning the stations wanting it, they still had the chicken and egg problem. That is, even though it was part of the standard, and even though there were TVs more and more having H.264 in it, the stations and the content owners who had their content being broadcast on those stations were very concerned for years, until really just about a year ago, that they were going to lose too many viewers by switching to H.264. They were going to be concerned about older TVs not working with H.264 yet, since the original ATSC1 standard only had MPEG-2 in it. Uh, so that has been one of the things that has held just H.264 getting used, let alone the big chicken and egg problem with ATSC3. So anyway, we really believed in getting H.264 out there. The benefits over MPEG-2 are roughly 2 to 1 in compression efficiency, and on top of that, H.264 has a lot of compression tools in it, if you will, that kind of clean up the video a little bit more. It makes it extremely, clean picture, less artifacty, with things like deblocking filters in it. So beyond the more channels, the pictures look better. And so, we started to develop, an ATSC1 encoder, feature with H.264 in it. And then we quickly realized that our customers really wanted both. They wanted to be able to do some MPEG-2 channels and some H.264 channels, because especially maybe their .1, their main channel that they might have on air, to really protect their viewership for that, they wanted to keep that in MPEG-2 and do maybe everything else in H.264 or some other combination. And so over the years, we had already had what's called a statistical multiplexer in our MPEG-2 ATSC1 encoder, and we realized that, well, if we isolate the MPEG-2 encoding in one StatMux pool and the H.264 encoding in another StatMux pool, it's going to be less efficient. We're not going to get as many channels through the system as if we can mix them all together. So we developed what we call mixed mode StatMux, so that all the channels are StatMux together into one pool, and you really get some great efficiencies from that. And statistical multiplexing is simply where you allow the bit rate per channel to vary with the content complexity, so that you're not wasting bits on a channel that may not have as much movement or action in it at a given moment. And then you can take those bits and use them in the another channel that might need it. And by doing that, you can get about 20% roughly more efficient compression. So that really, that turns into a couple extra channels sometimes, or just more improved quality.
Yeah,
So
and
that
there's an art to it too. I mean, I know you've talked about Anton Capello with me and what he did at his station. He was
Mhm.
able to push the limit with StatMux, and able to achieve these very high quality looking video streams with very little data capacity required.
Mhm. That's great. So we got that into the market a few years ago, and we still had this, concern from broadcasters, customers, our customers, we had a few channels, a few stations who started just barely using H.264, just turning on a channel or two. And it's starting to grow it a little bit. We had a few stations who were doing, up to almost 20 channels, and they were being successful. And so this finally started to break the break the problem open. That people realized that, hey, since about 2012, every TV can decode this H.264 now, and some of them even before that. So we're beyond, more than 10 years past that point. And the way that consumer electronics and prices have come down, the people buying TVs more frequently because they're so less expensive and things like that. So the population coverage for H.264 had really reached that critical point, and we finally got some larger station groups to say, "Hey, we're going to go for it." And the biggest one was last year. Bridge News worked with us, and we did their whole nationwide station coverage, which is about 80 stations in H.264. And right now they're on the air with 16 or 17 H.264 channels across the country, and just a handful of phone calls from, there's still one or two people out there that, hasn't changed their TV in 20 years. But we were joking around with some people at NAB, anybody who calls who doesn't have a TV that works, some of the stations go and buy one and give them to the person. So it's that, lower percentage. So we were thrilled with that, and thrilled that it's finally going out to the market. We saw a lot of interest at NAB just 2 weeks ago.
There is one interesting challenge that we had during the deployment in the early days of some of these H.264 deployments. Some televisions, even though they could receive streaming H.264, they could not receive the over-the-air. It turned out that the way you signal in the stream, there are multiple places in where you can signal that you have an H.264 codec instead of an MPEG-2 codec. So about 5-7 years ago, some people did early trials on 264, and then they came out with publications saying that, hey, half the people don't receive television using 264. It turns out that's actually, the reason was because the television actually did not recognize the fact that you had an H.264 stream. And there are multiple ways to signal that. There are at least 3 known ways where you can signal the fact that you are carrying an H.264 codec. You can do it in the transport stream, you can do it in the header, you can do it in auxiliary data. And different television manufacturers are looking at different spots to see, do I have an H.264 stream or an MPEG-2 stream? So if you didn't cover all your bases, you are missing some of the television sets. And we discovered that after about a year. We got specific televisions were not picking it up, and then we would buy those televisions, bring it to our lab, and then figure out, oh my God, it's looking at a different spot in the stream to look for the codec. So we covered all the bases. We kind of let everywhere where we can tell the television that it is a H.264 stream, we put it in. We put those flags in. And then that coverage vastly improved, right? Now we hardly get anybody with a 2012 or 2013 television, anybody beyond that, we hardly get any complaints that they are not able to receive the audio. A lot of times what would happen is they would receive the audio, but not the video because it didn't recognize the codec. So we have plugged all those holes. And now we believe that we are well above 90% of the people who have a newer television set, they should receive all the streams just fine. And so that's actually improved a lot in the last few couple of years, especially with Bridge. Bridge has got, as Jeff mentioned, we set up their entire infrastructure from Detroit. And the other thing we did, the other big innovation we did was to make it, we built a centralized data center with a nationwide distribution that really helped their operations, including conversion to H.264. If they wanted to do some, channel lineup changes, all that became really simplified. And when they rolled out the system, we have had very, very few complaints. And by the way, the other interesting thing that we do is in the MPEG-2 channels, we tell television owners, please scan your television set this weekend, because we put a scroll, public service announcement that tells customers that please rescan your television, because you may be picking up a few more channels. Because if you start a broadcast of H.264, you have to rescan the television for the television to recognize that these channels exist in the guide. So we did that public service announcement in all the cities. We were doing it once a week, sometimes 3 times a week, just to let people know, hey, rescan your television, you may pick up a few more channels. And that helped as well, actually. Those two things really has changed the game for receiving, with ATSC one, receiving the channels on existing television sets.
Yeah, my 2018 Samsung TV didn't even need a rescan. It just
So
as
it didn't
soon
need a
as
rescan.
yeah,
Wow, that's
I
pretty
mean,
cool.
I just turned on the TV, popped the channel, and it just instantly knew to start decoding H.264.
My bet is their software, right? They are probably doing a periodic scan in the background that
Yeah.
we, looking for the guide. They update the guide. Some older television sets may not update the guide, or even if they updated the guide, they may not know to look for a different codec, for example. So you're right. I mean, so what we discovered was the PSAs helped as well. In Texas, we have a customer who runs 20 channels, all SD. Okay, he's running all 20 SD channels. He told us that he runs, even now, after several months, he's still running public service announcements once a month to tell people, hey, rescan the television, you may be picking up a few more channels. And guess what? Some customers did tell him that that did happen. So it's an education as well, right? In addition to
Well, it's
yeah.
also hard, how well the hardware at the consumer side is working, just
Yes.
like you mentioned. The Samsung TV's got some smarts in that
Yes.
underlying software to do that. Your budget TV from 10 years ago may not have that
May not have.
functionality.
Exactly.
So
Right.
I just want to say that for the one TV in my video that I did with the H.264 testing with the station in Buffalo, New York, that TV wasn't even able to receive the audio. So the audio wasn't even playing, and it's just standard AC3 audio. So there's something in the logic of that software that's just not
Which
accepting.
television set was that?
It is a brand that is no longer making TVs. It was made in like 2008. It is Aria, which doesn't even make TVs anymore. It is
So the
an
I know,
artifact on our
okay.
wall.
The problem is I suspect in 2008, right, their software probably didn't even recognize the fact that it probably thinks it's an unknown codec or something like that, some error, and then it just errors out probably.
Yeah.
Because the standard was standardized in 2009 or 10, if I remember correctly. And then since then, most television sets included it, and streaming started to appear in 13, 14. So most television sets by that time frame started to say, hey, 264, no big deal, right? I can just use it and play it. They had software drivers to just play it. So it's been, I would say that anything beyond 2012, 2013, we should feel reasonably, except we found one Samsung set, right, Jeff? I mean, in Pittsburgh that consistently, the funny thing is that a year before that was playing fine, but the year after that was not playing. For some reason, it was having trouble, but we never figured out why.
Yeah, that was a 10 or 11-year-old set, I think.
Yeah, it was 11-year-old set. 2015 set was not playing, 2014 was playing fine. So
yeah, the oldest Samsung TV sets that we have are 2014s. So
they play fine.
Those are playing fine.
Yeah, try a 2015. I think a 2015, we had a problem with the 2015. 2014 was good.
Really? Maybe it's like a low end model, or maybe a model that was, who knows? Who wrote the software at the time? Who knows?
Right.
Yeah.
Right.
Now, I'd like to talk a little bit about your Lux encoder, I believe it's called, for the solution. It said on your website 24, up to 24 possible streams of video.
Mm-hmm.
I'm curious, is that a software limit? Because in theory, you could compress things further. You could have, 35, 40 in theory if you really wanted to add some compression. If obviously there's limitations with the iframes and, how much you can save. But
so that's really based on H.264 and SD, right?
Okay.
That's what we can get with our StatMux advantage. That helps squeeze in even further. But that's like we said, we have one customer in Texas doing 20 channels. Bridge News is at 16 or 17, and they're adding. We'll be adding. So 24 we've run in our lab. We don't know anybody who's doing that yet out in the field, but it's practical. And then if you wanted to go beyond that in SD resolution, you'd need a next generation codec.
So, one of the problems you also have, Dylan, is that the overhead of PSIP and audio starts to eat into your each channel now. All of a sudden, you need 64 to 128 kilo, at least AC, since it's AC3, you need 128 kilobits of audio for every channel, right? If you start doing more than 24 channels, that you're already eating up 5 megabits or 6 megabits just for the audio alone. And then PSIP data for each channel, you need to have about 150 kilobytes or kilobits per second of PSIP data to describe the channels. When you add up all that, right, all of a sudden you're eating into, you can't do, even if the video codec can support a few more channels, the audio overhead and the PSIP overhead and everything starts to add up at that level. And what we discovered was getting beyond 24 SD channels, SD good quality. And you must have seen the video in our in your Buffalo station. There will be some talking heads which are very easy to code, very low bit rates. The video is coded at very low bit rates, and each of them can be individually set. And if there is a little bit more higher action channels, we give it more bit rate, higher bit rate, average bit rate settings, and things like that. Even when you play all those games, when you get beyond 24, we found that it's pretty hard. You're pretty hard pressed to add more channels. So the limit is imposed by the fact that you have 19.38 megabits per second that you have to allocate between all these guys, including audio and PSIP. And that starts to eat in. The audio and PSIP starts to eat in,
Yeah, when I did a TS reader scan with that station in Buffalo, everything was around a megabit per second. And what's interesting is there were stations from Tegna and Nexstar in the same market that had MPEG-2 video at 700 kilobits per second. So that's where I'm getting at with, in theory, more could be done. Obviously, is the picture quality going to be fantastic? No. But if you tweak some things, if you do an Anton and you sit there and
yeah.
I mean, it depends, on how much, effort you want to put into the stat mux. But, I was kind of surprised. I'm like, man, they're allocating some decent data capacity to these streams.
Yeah. Oh, they were doing MPEG-2 at 700 kilobits per second?
Yeah, it was ranging from 700 and 900. And that was on a Nexstar station. The video quality was bad, but it was watchable. And I can send you the TS reader.
Sure. What did you think of our MPEG-4 quality? Was that watchable?
So what I did, and fundamentally, this is, in my opinion, a little bit of an issue because I like comparing the video quality to what is available if you were to watch it directly, because most of these channels are fast channels that you can watch on their respective website or on Pluto TV or Plex Free TV and some of these fast, free outlets. And, I think I saw that on the, what was it? One of the sports channels, it was beIN Sports Extra, the beIN Sports Extra and beIN Sports Extra en Español. Both of those were around 1.8 to 2 megabits per second, 720p on, on the website, on their respective website.
Sure.
Where with yours, it was like ranging to like 1.1, 1.2, and it's not that far off. And I was just doing this thought process in my head. I'm like, technically you could get that compression down a little bit more. And what if you did make it 720p? Because I've noticed that with all of your, encoder type, stack that you have, it seems to be limited to like, oh, you can only do 4 HD. But from a technical perspective, as long as you fit within that 19.39, you get that, 1.2 megabits per second, let's just say, is that possible? Could you start up converting all those to 720p and keep the same bit rate, just compress it a little bit more? And what's that trade-off in visual if it's a higher resolution, but it's just slightly more compressed versus a lower resolution, but it looks better?
We can play the games. All these the key is then you need the station owner to be very careful because we don't know what channels they are deploying. So we build a generic stat mux, right? And we give them the handles. Gotcha. The problem is they need to tweak those handles, sit there and tweak the handles, and they can do it. Frankly, they just paid some attention because we are not able to see what their video quality looks like on their channels in that location, that market. So we just give them general directions. We give them general directions on how to tune it. But you're absolutely right. If you tune those channels very carefully, if you knew the nature of your channels, we give you the average peak. We allow you to set the average peak and the resolution and the frame rate. All of those you can tweak for each channel. So when they sit there and they tweak those channels, right, they can get it down to a point. You're absolutely right. You can squeeze in more for slight loss in quality, which everybody may think is fine, but we don't quite control that at each station. So we have 600, 700 stations where people just do their own thing. And the bridge is something that we just saw, you publish it. We are seeing that for the first time. We have no idea what is going on out there in the field because we don't control it. We just give them all the handles, and then it's really a software encoder. If you think about our encoder, it's running on servers and GPUs, and it is completely flexible. It was all written in Linux. So it's a pretty flexible platform that station owners can tweak. And some station owners sit there and tweak it ad nauseum. They look at the quality and really get it down pretty good. Some don't. Some don't care. They just set it to default and leave it there and keep running.
So let's just say there's no technical limitation with your product to have 15 720p channels with stereo audio, as long as
if the quality supported it. If the quality is supported, the answer is yes. But I doubt you can get 15 and 19 megabits trying to do 1 megabit channel, because if you did 15 channels, right, you have to have 15 megabits of video. Yeah. Now you have to add audio on top of that and piece of data on top of that. So you'll go above the 19. So you may be lower than that, than 15. But you know what? People have to try. They have to see what the quality of their content is and try and be satisfied with what they need. So,
well, and there's also, definitely.
I'm just going to add, what you probably observed also is that since Bridge, I think, is running 16 channels or 17 or something, the StatMux has got some breathing room, and so it's going to use every bit. It's not going to throw nulls in there. So, it may have been running at that 1.1 or whatever, but only because it didn't have enough to do. So
so when I did the TS reader, I think it had 14 channels. There was about a megabit of null packets, but then they added another channel on. So I think they were expecting that.
They were working, People are constantly experimenting with this type of thing, and it's too easy to do that. It's easy, almost it takes you 2 minutes to add a channel or remove a channel, and do it on the fly. So people have been playing with it a lot, actually, especially with the 264 when the channel count goes up. And so there is the other aspect of this is, remember, the first channel in the case of the Buffalo station, the first channel is always MPEG-2. So they are running one HD channel at MPEG-2, which is eating up a lot of they put a lot of bits towards it. And then the remaining channels is whatever they get, right? That's what they do. And everybody is doing that, because I think there is a requirement, the FCC has a requirement that your first .1 has to be an MPEG-2 channel, is what we have read. Our understanding of the FCC is that's what you have to do.
But it doesn't have to be 720p, which is what they were doing, eating up 5 megabits per second.
That is correct.
If
you could do an SD MPEG-2 and then do all that.
I know.
We have suggested that, by the way. We have suggested that to some of our customers. I mean, they have to do what they have to do. The .1 is more valuable, and they have contractual requirements to do certain things. That's why they do it the way they do it.
So that's the biggest thing.